Okay, so this week and next week we're going to be solving systems of equations. So we're going to be here a while, so hopefully we get pretty good at this. Three different ways we can solve systems of equations. The first is graphing, and ideally the best circumstances for solving by graphing is if we have equations in standard form, but to be more specific, in standard form where all of your numbers are multiples of each other or factors, so that way we can find the intercepts nice and easy. Unfortunately for us, that's not going to be the case for all these today. But let's try it out. So we're going to do this one equation at a time, and we're just going to graph. We're going to graph both equations. So if I have 2x minus y, copy it down, and I just want to find the x and y intercepts. So if I say, what is y when x is 0? And what is x when y is 0? Okay. So you can think of that, if you don't have to write it down every time, is what happens if we cover over the left term, what happens if we cover over the right term, and then we solve for the variables left over. So in this case, 2 times 0 cancels out, negative y equals negative 1, so y equals positive 1. So we know we have 1 point at where x is 0 and y is 1. So I can plot this one here. And 2x minus 0, so that 0 goes away. So x would equal negative 1/2. So see, there's the problem. If this was a nice whole number, it'd be easy to plot, and we could connect them, we'd have a line. Unfortunately, we have the point negative 1/2, 0. And our grid only counts whole numbers, so we just do our best. And we kind of get an idea. We see the slope, it goes up by 1 for every 1/2 it goes over. So to go over a 1 whole, it would have to go up 2. So we can fill in the blanks here. Okay. All right, so there's our equation for 2x minus y equals negative 1. All right, so then we take our second equation, which is even worse somehow. So if I look at this, if I cover up my x, 2y equals negative 16. So when x equals 0, y is actually going to equal negative 8. And skip the word here. But then when we cover up our y, so we have 5x equals negative 16, or x equals negative 16/5, which is not ideal. So we have negative 16/5, 0 as our other intercept. So the problem there is that neither of those points will be easy to graph. So we can say 6, 7, let's say negative 8 somewhere down here. Negative 16/5, it's negative 3.2. So that's right about, kind of close to there. And then we can connect them. And we see it kind of looks, because we know our answers, I think on all these, come out to nice integer values. So we see that they intersect at this point, -2, -3. And that's really what system of equations is about, is if you have two lines, where do they meet? What is the solution for both equations at the same time? So let's test it out. So if I substitute these x and y values, so I have 2 times -2 minus -3, does that equal -1? So it's -4 plus 3. -4 plus 3 is -1. Good, that checks. It also has to work in the bottom equation. So remember, x and y are swapped around here. This isn't even proper standard form. Killing me. So 2 times -3 plus 5 times -2, does that equal -16? Let's see, 2 times 3 is 6, 5 times 2 is 10. Those are both negatives, so you put them together, 6 and 10 makes 16. This checks. Okay, so there's the idea. We want to plot both lines, we want to see where they meet, and then we take that value, we substitute it back in the equations to make sure it works. So there's no excuse to get anything wrong. Okay? Fortunately for you, these are all multiple choice. So you just have to find the graph that looks closest to your equation. So even if it doesn't work out perfectly, like this one here, 5x plus 4y equals negative 4. So if we say 5 times 0 plus 4y equals negative 4, we know we're going to have 1 point at 0, negative 1, because this will cancel out. Divide both sides by 4, we get y is negative 1, right? Let me erase this so I have more room to work. I'm going to erase, there we go. But our second intercept, so we'd have 5 times x plus 4 times 0 equals negative 4. And that's going to come out kind of ugly because we have to divide both sides by 5. So x is going to equal negative 4/5. So we're going to point at negative 4/5, comma 0. But we don't need exact, we just need close enough. So if we see 0, negative 1, it's not here. This is 0, negative 1. This is 0, negative 1. This is 0, negative 1. And then we should have a point, that same line, on negative 4/5 and then 0. So this looks pretty good. This one's at negative 4. That's not it. This one, it's kind of close. We'll check it. So just by graphing that one line, we've narrowed it down to just 2 more answers. So we plot the other line, confirm the graph. It's either going to be negative or positive, which helps out a little bit. So really it's just practice, can you graph equations, especially from standard form. Almost all of these are in standard form. So it'll be nice practice of graphing. And then we'll get more into the more mathematical ways of solving system equations later on this week. And just as a reminder, I forget which question was. Oh, here it is. If you see y equals negative 1, remember that's a horizontal line where the y value is always negative 1. So just by looking at that, I know it's not these 2 answers here. Okay, so practice it. Practice graphing. I'll come back if you need some help.
Please.